Hi guys, welcome back. Today we're doing nearest exit from entrance in maze. So we're given an m by n matrix called maze, which is 0 indexed with empty cells represented as a period and walls represented as a plus sign. And we're also given the entrance of the maze where entrance is entrance at row, comma, entrance at column denotes the row and column of the cell you're initially standing at. So in one step, we can move one cell up, down, left, or right, and we cannot step into a cell with a wall. So these are the walls, which are the plus signs in the grid here, and we cannot step outside of the maze. So we cannot go out of bounds out of the maze. An exit is defined as an empty cell, so not a wall, that is at the border of the maze. So anything on the perimeter that's not a wall and is also not an entrance. So the entrance does not count as an exit. And they want us to return the number of steps in the shortest path from the entrance to the nearest exit, or -1 if no such path exists. So this is also pretty similar to that other problem that we just did, which was the shortest path in the binary matrix. The only difference is now we have walls in here as well, which we need to look out for. So, and we also need to start from the entrance instead of 0, 0 or whatever. So we basically want to do a BFS from our starting point, which is the entrance. That's going to be like our route for the BFS. And we're going to explore from here outwards, like layer by layer, until we reach the perimeter, like any point of the perimeter, I guess, because we want shortest path, and then we just need to check that there's no wall there. So that should be pretty straightforward. So we're going to start by initializing, I'm just going to denote m for the rows and n for the columns in the maze so that we can just refer to those. So m is maze dot length and n is maze at 0 dot length. Okay, and then we want to set up our queue so that we can start doing our BFS. So queue, and we're going to store an int array. And then we also want to have a visited array. So boolean visited is new, and then we're going to make it size m, by n. So our queue will initially start out empty, and so let's copy and paste example 1 here so we can see what's happening. So okay, so there's our input. Okay, and our entrance is at 1, 2. So 1, 2 is going to be this one. So we start here. Okay. And so our visited will be, so we'll start out with everything false like this. And I'll just copy and paste this because it's all the same. Okay, and then that is going to be more spaced out like that. Okay, so this will be our visited array. And then we need to add the starting point, the entrance, into the queue. So we'll say queue.add new int, and we'll add the entrance because we're given, I guess we're given the entrance as an array. So we'll put this coordinate for the row and this coordinate for the column. So entrance at 0 is the row and entrance at 1 is the column. And then we're also going to keep track of how many steps we take because we need to return that at the end. So the steps will be here. So let's comment row, column, and steps so it's clear. So now our queue will have an array which has 1, 2, 0, because 1, 2 is the entrance, the row in the column for the entrance, and then 0 is the number of steps we've currently taken, which is 0. Okay, and then we need to set our coordinate at visited for that coordinate into true to signify that we have visited that. So entrance at 0. Hold on, why is there 2 of these? Okay. Oh, because, okay, no, I'm following now. Okay, entrance at 1 is true. So entrance at 0, entrance at 1 is going to be 1, 2. So if we go to 1, 2 here, then this will turn into true. Okay, so now that we've done that, we need our directions array, so that because basically how we're going to visit the neighbors, like from here or something, is like we need to go up, left, right, and down, as long as there's no wall there. Then we need to do a BFS like going outwards, right? And so to visit outwards to all the neighbors that are up, down, left, or right, we will need to know which direction to go in. So we're going to set our directions array, and we'll just say 1, 0, negative 1, 0. Why is this acting up? 0, 1, and 0, negative 1. Okay, and if you guys don't remember what this means, take a look at any of my recent videos where I explain how this works. But we're just going to go into the BFS now, so while the queue is not empty, then we will keep exploring. So we're going to set the top cell to the top cell in the queue, which is going to be this. So we remove that and store it into cell. And then we will just assign the row to this, the cell to this, and the steps to... I guess we don't need to do the steps because we'll just increment the steps as we go. But at least the row... Actually, no, we'll do the steps. So we'll say row is cell at 0, column is cell at 1, and steps is cell at 2. Okay, and then we're going to loop through all of the neighbors, which we will do using directions. That should be plural. So for int direction in directions, then our new row will be our current row plus directions at 0, or direction at 0, sorry, because it's for each direction. So our current row is going to be row, and then plus direction at 0. Our new column is the same thing, so column plus direction at 1, and int, okay, so, okay, yeah, so this is our new row, new column. Our steps is just going to be our original steps plus 1, so we'll just do that as we go. So we're going to now need to check if our new row and new column is actually in bounds, which if we'll know it's in bounds if it's within the bounds of the array, so not less than 0 and not greater than the length of whatever row or column, and it cannot be a wall. So if new row is greater than or equal to 0 and our new row is less than m, and new column is greater than or equal to 0, and new column is less than n, and it is actually a empty space, so and maze at new row, new column equals period. Oh, and we have not visited it already, because if we've already visited it, then we don't need to re-explore that. So that should return false, and if that's the case, then, sorry, this is kind of bothering me, so I'm gonna reformat this. Okay, if that's the case, then we will check if it's not, so this is to check if it's an open path, okay, and then if this is a exit, so it's on the border, and the entrance, then we will just return the number of steps that we've taken because we found our exit. So if new row is 0, or it is m-1, because that would mean that it's the last row, or new column is 0, or new column is n-1, that means it's on the border. So then we can return steps plus 1, because that was the original number of steps we took before we took that step to that border, and then we need to add 1 for that extra step that we just took. So if that's the case, we'll return steps plus 1, otherwise we will visit that cell. So visited at new row, new column is true, and we'll add it to the queue to explore in the next round of our BFS. So new int, new row, new column, and we'll increment steps. And then we'll just do this for the entire grid. If we go through the entire grid and find nothing, we'll return -1. So yeah, that should be that. Oh. Oh. For in equals. Okay. I guess my videos are not complete without at least an error somewhere. Okay, let's go over time complexity. So, okay, if we think about the algorithm, right, we start at the entrance and we do a BFS from going out from here, so one layer at a time. So one layer would be up, left, down, right, and then the next layer from here would be this, 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 and this, and then from there would be this, this, and this. So all in all, we're visiting every single cell exactly once. So that is going to be O of m times n, where m is number of rows in maze, n is number of columns in maze. Okay, and again, so that's all going to be pretty much in this BFS here, where we explore every direction of every cell exactly once. Because if we've already seen it, then like we mark it as true and we don't revisit it. Okay, and then our space complexity is, so okay, actually let's look through what we have here first. So we have our visited array, which is size m by n. So we already know we have that. We have our queue, which only stores cells that we are processing in our BFS, but we process every cell exactly once, so that's also going to be m times n. We have our directions array, which is constant because it's only storing 4 directions, and that's it. So basically this is negligible. M times n plus m times n gives us m times n once we simplify it, so that's also m times n. And that is it for this video. Thank you guys for watching, and like and subscribe if you found it helpful. Bye!